Have you ever been told to draw a perfect right angle, but without a protractor? It sounds a bit tricky, right? But it's actually a really fundamental skill in geometry. Today we're going to tackle a question straight from a real exam paper and show you exactly how to master these geometric constructions, one precise arc at a time.
So let's just get right to the heart of it. Picture this. You're in an exam, you've only got a ruler and a compass. How in the world do you create a perfect, spot-on 90-degree angle? It's a classic problem, and you know what? The solution is actually really elegant and surprisingly simple.
All right, let's dive into this 90-degree challenge by taking a look at the exact question students were up against.
So here it is. This is the question word for word as it appeared on the exam paper. We've got a line, AB, and a specific point on it, P. The task is all in the details here, so let's really focus on what it's asking for.
So the mission is crystal clear. We need to build a line that's perfectly perpendicular to the line AB, and, this is key, it has to go directly through point P. And notice that word. It doesn't say draw, it says construct. That's a huge clue that we need to use a very specific geometric method.
Okay, so before we even think about making any marks, let's go over our toolkit. Because in geometry, the rules of the game, what you're actually allowed to use, that's everything.
The exam paper is really, really specific. Your whole toolkit is just these three things: a ruler for your straight lines, a pair of compasses for drawing arcs, and of course, a pencil. Notice what's missing? Yeah, no protractors, no set squares. None of the easy stuff.
And here's the other big one. This is from a non-calculator paper. That just proves the point, right? This isn't a test of your number crunching skills. It's a pure test of your understanding of geometric principles. All right, now that we know the rules, let's get to the fun part, the actual construction. I'm going to walk you through this step by step, and you'll see just how logical this whole process really is. So, our very first move with the compass is the foundation for this whole thing. The goal right now is to create two perfectly symmetrical anchor points on either side of P.
Here's how you do it. Put the pointy end of your compass right on point P. Now open it to any width that feels right. It seriously doesn't matter how wide, just pick one, and draw an arc that swings across the line on both sides. What you've just done is create two new points that are the exact same distance from P. That's the secret sauce for what's coming next.
And now for the most important step. We're going to use those two new points we just made to build upwards and find the peak of our construction. Okay, so put your compass point on one of those new marks on the line. Draw an arc up above the line. Now, and this is super important, without changing the width of your compass, move it over to the other mark you made and draw a second arc that crosses the first one. That little X you just made, that point of intersection is exactly what we've been looking for.
We are on the home stretch. All the tricky work with the compass is done. Now it's time to bring in the ruler.
So grab your ruler and just connect the dots. Draw a perfectly straight line from that intersection point you made in the air straight down through our original point P. And that is it, a perfect constructed 90-degree angle. Awesome.
Now, hold on. Constructing the angle correctly is one thing, but making sure you get full marks in an exam, that's another. There is one final, critical instruction on that paper that you absolutely cannot, under any circumstances, ignore.
It says it right there in black and white. You must show all your construction lines. This isn't just a friendly suggestion, it is non-negotiable. For the person marking your paper, this is just as important as the final answer itself.
So what does that actually mean? It means do not erase those arcs. They aren't messy scribbles. They are your evidence. They prove to the examiner that you followed the correct geometric method and you didn't just guess or, sneak in a protractor. Those lines are your proof, and they're what get you the points.
Okay, let's do a super quick recap of that whole process, just to make sure it sticks. It really is a simple, repeatable method once you've done it a few times. So it's just a simple three-step process. 1, you draw an arc from P to get 2 points on your line. 2, from those new points, you draw 2 more arcs that cross over each other. And 3, you rule a line from that intersection point right down through P. That's it, done.
And here it is, the final result. A clean, precise construction where all those arcs are left visible as proof of your work. It's a really elegant solution, and it's a skill that, once you get the hang of it, you'll probably never forget.
So there you have it. That's how you solve a classic construction problem. It really makes you think, doesn't it? If we can create a perfect right angle with just these simple tools, what else is possible?
Bisecting an angle, constructing a perfect hexagon? The power of pure geometry is actually pretty fascinating to explore.